This meeting is being recorded.
In problem 2.8, we're asked to draw all the lone pairs on each of the oxygen atoms in the following structures. So in the textbook, you're given, I think, 10 total examples, but we'll work through A through E here, and then you can try the rest on your own. So they advise you to review table 2.2, which I've placed below here, and see if you can identify all the lone pairs without having to count. And by counting, they mean figuring out, do we have the 6 valence electrons that a neutral oxygen would have? Or in the cases where we have a formal charge, do we end up with a -1 formal charge? So let's look at our first example here. We know that oxygen is neutral when it has 2 bonds and 2 lone pairs. So that's what we see with this oxygen here. It's neutral, there's no formal charge, so we know that it would have 2 lone pairs since it already has 2 bonds. The next molecule, molecule B, we see 2 oxygens with neutral charges, or neutral with no formal charge. So we know that since they have 2 bonds, each of these would also have 2 lone pairs. Our next example, letter C here, we're going to see that again. So this carbonyl, that oxygen has 2 lone pairs. Down here, we also see 2 lone pairs on this oxygen. All right, so our last two examples here, D and E, both have negative formal charges on an oxygen. So we know what's going to happen up here. We're going to have 2 bonds and 2 lone pairs for that neutral oxygen. But down here, we're going to see 3 bonds and, the other side, we're going to see 3 lone pairs and 1 bond will give us that negative charge. So each of these oxygens will have 3 lone pairs in this examples D and E to give it that -1 formal charge. So we'll do a quick calculation with example A and E we'll use. So the formal charge here, we would have 6 valence electrons because oxygen's in group 6. So a neutral oxygen would have 6, and then minus, know that we add half of the bonding electrons, so we can count the line, so 2, plus all of the lone pair electrons, 4, gives us that formal charge of 0. So if we go over to E, we'll calculate the formal charge on the oxygen. We'll do the same equation, so we'll do 6 for valence electrons minus the number of lines, 1, so half of the bonding electrons in that 1 bond, plus all the lone pair electrons, so all the dots, so 1 plus 6 gives us 6 minus 7, so we end up with that -1 formal charge.